Use the limit definition of the derivative to find the derivative of the function f of x equals 5 over x. Okay, so the limit definition of the derivative, that is f prime of x, is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. Okay, so in this case, we have, say, f prime of x should equal the limit as delta x goes to 0 of f of x plus delta x, so we'll replace the x with an x plus delta x, minus the original function f of x, all over delta x. Okay, so we have to do some simplifying here. Somehow we have to cancel off the delta x in the denominator, so we could plug in 0. At this point, we can't plug in 0. It looks like we have a compound fraction here, fractions inside of fractions. So let's do a little algebra, and let's get rid of the fractions within the larger fraction. Okay, so let's get a common denominator in the numerator, so we could multiply this first fraction by x over x, and this second fraction by x plus delta x over x plus delta x. We get a common denominator in the numerator. So f prime of x should equal the limit as delta x goes to 0. Okay, so we have delta x on the bottom. On top, we've got our common denominator of x times x plus delta x. It looks like we have a 5x minus, we don't need that parenthesis, 5x minus 5 times x plus delta x. Okay, so we have a 5x and a minus 5x, so there's going to be some canceling there. So let's see what we got. F prime of x is now equal to the limit as delta x goes to 0. And on top, we still have our fraction x times x plus delta x. And on top, okay, we have a 5x minus a 5x, so they cancel. And then we have a minus 5 times delta x. All right, looking good. So now we have a single fraction on top, and we can look at this like we have a fraction divided by a fraction, so we could change that to multiplication. So say the derivative is equal to the limit as delta x goes to 0. Okay, so we have a minus 5 delta x over x times x plus delta x. And we can multiply this by 1 over delta x. That's the delta x on the bottom here. It's looking good. We have a delta x on the bottom and a delta x on top, so they cancel. All right, so derivative equal to limit as delta x goes to 0. So now let's see, what do we got? We have a negative 5 on top and an x times x plus delta x on the bottom. Okay, now this is all algebra, no calculus yet. We're finally at a point where we can apply the limit. So this is the step of calculus. So we can apply the limit, plug in 0 for delta x. So that's negative 5 over x times x plus 0. Or simply negative 5 over x squared. And there is our derivative. So what we've seen here is that when the function is 5 over x, the derivative of the function is negative 5 over x squared.